motion problem.
Lesson 34, uniform motion problems. D of 1 plus K equals D of 2. What does D stand for?
Distance.
Distance. So the distance that somebody has gone plus another distance, let's say 40, equals the distance that D2 has gone. So it ends up looking like that. Because sometimes someone will travel somewhere and stop, and somebody else will travel even further than what they went, but you want to know how much further they traveled. So again, we're going to use the distance equals rate times time equation. So if we have the distance of 1 equals the distance of 2, we have RT equals RT. I'm going kind of quick because you guys already know all this stuff. But the difference is we don't have D1 equals D2 in this lesson. We have D1 plus K. So now we have the distance, or RT, of the first person plus some random number, let's just say 40, equals the total distance of that second person. So the only thing we're doing differently in this is we're adding or subtracting a number from one of the distances in order to make them equal. So that brings us to story problem on the bottom of page 155 about a young lady named Millicent. That's probably what Kendra's parents were going to call her, but somebody talked them out of it.
Actually, no.
And Riley was actually going to be named Beauregard.
Actually, I was gonna be a Dana.
A Dana?
Yes, that's what my dad wanted.
Oh, I'm so glad they named you Kendra.
Dana or Dana?
Dana.
Dana's an ugly name. I never met a good-looking Dana.
Dana sounds like a Russian
It's
name.
true.
Dana is one of those
Miss.
boy-girl
Mr.
names. You know, what do they call those?
That's
A
okay.
unisex name or something? Like
There's a Dana in
Chris
this
or...
book I read. There was like this big fat guy, and then there's like a really old lady's daughter, and she was like, yeah.
Her name was Dana. Your name was going to be Christine? Yeah, dark
Aw,
school. Little... Oh, God.
That's
Fine,
so
Gil.
weird.
My dad always said that if I would have been that he wanted to name me Mahitable.
What?
That's what he said he wanted to name
For a
me.
girl.
I don't know. I don't know that it's anybody's
Mahitable.
name.
Yeah, I found an old book in the garage. They said my name would have either been Levi or James. So my dad was
They
gonna
thought
name
you were
me
gonna
Levi.
be a guy.
They did.
See, I don't like guys' names that could be girls' names, but I like girls' names that could be guys' names.
Like Alex.
Yeah. Or like
Like
Jesse.
Alex.
Jesse could be a guy or girl, but I would rather have a girl named Jesse than a guy named Jesse.
I like Alex.
Yeah. Ashley. I've known a couple guys named Ashley.
That's more of a girl name.
Yeah, it's a little bit more feminine.
I would
Yeah.
never put my kids through that.
But I mean, I've known guys named Stacy and Kelly and Kim.
Kelly's actually pretty popular. For
Yeah.
guys' names.
Oh,
Yeah.
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 Like Kelly's Heroes.
That would play this one.
My gosh!
It's crazy.
He just said
Uh-oh.
Okay, we should do our
Somebody
lesson now
that knows
because
movies, huh?
there's like.
Okay, anyway, back to lesson 34. So Millicent. Millicent began her journey at 6 o'clock in the morning, and she is traveling 50 kilometers per hour. Okay, at this point, we're not going to worry about anything except distances here. Beauregard began to chase her at 10 a.m. at 60 kilometers per hour. What time was it when Beauregard got within 40 kilometers of Millicent? Did he ever catch up to her?
No.
So the distant Millicent went was that. Beauregard never caught up to her. He got
40 kilometers.
this far, but he was how far from her?
40 kilometers.
So there's a 40 kilometer distance here that he never made up for. So if I want to set my distance as equal, I'm going to take my distance of Millicent, and that would be equal to my distance of Beauregard plus 40. Now they're going to be the same distance. All right, so once I get my equation there where I'm comparing my distances, now I can start throwing in the other junk that I know. Okay, so let's reword this or rewrite this. Instead of distance of Millicent, let's write rate times time equals rate of Beauregard times time of Beauregard plus 40. So now I got to come up with what both of my RTs are. All right, so do I know Millicent's rate?
650.
50. All right, so we'll put a 50 there. Do I know Beauregard's rate?
60.
60. Okay, and we have the plus 40. Do we know anything about time?
They were 6 hours apart. 4 hours apart.
Did they leave at the same time?
So you can do
TM equals TV plus 1.
So our time is TM equals time that, what was this guy's name? Beauregard travel, or he was on the road, plus 4. Now they're equal. If we add 4 hours to Beauregard's time, it'll be the same as Melissa.
Do you like saying his name?
Beauregard?
I kind of do. Beauregard. Especially since it was the name I
Melissa, kind of a pain in the neck to say, but
It's
Melissa.
kind of like Melissa,
That's dumb.
but
That was Melissa.
What was time?
All right, so at this point, we don't know the time of Millicent, and we don't know the time of Beauregard. But we do know that TB plus 4 is Millicent's time. So instead of putting TM down here, we're going to put TB plus 4. Okay? And then instead of, well, we know the time for Beauregard, and so we could just put that in there.
time regards
We can just put TB in here. Okay, so that being the case, there's your equation. So go ahead, and the question that they're asking for is,
what time?
what time was it when Beauregard got within 40 kilometers of Millicent? So when Beauregard got right here, what time was it? So when we find the time of Beauregard, are we finding a clock time?
No.
Never. You will not ever find what time it is o'clock. You will only find hours, and then you're going to have to add it to, you know.
What time did they start?
10, that's
Um,
when he left.
Yeah, he left at 10, and she left at 6. Okay, so go ahead and find TB, time of Beauregard, how long it took him.
I got it.
2 of them. Oh, 16 hours.
Were they like running
Well, they're going 50 kilometers per hour and 60 kilometers
You
per
have to
hour.
know
we
if
do it
it's
on horse?
AM or
As you can tell by their names, they're obviously aliens.
They're aliens. So 60 kilometers per hour is, what, about 40-ish mile an hour?
They're four-wheeling.
They're four-wheeling. So, somebody said that they got this time to be 16 hours. So, he left at what time?
10.
10. So what time was it when he?
2 o'clock.
2 o'clock.
Okay.
Ooh.
Do you have to say if it's AM or PM?
Well, you're not going to go backwards in time. But yeah, it is good to know whether it's AM or PM, because if you say 16 hours later and you left at 10 a.m., it's obviously going to be at 2 a.m. the next morning. But it is good to say that.
Really?
And that's the lesson.
Kind of. Okay,
Let's have it.
let's do another one. The Sheriff of Nottingham and Robin Hood. One of the things I like about this one is the sheriff catches him.
Oh, it is.
You want
Why?
what? You want?
I don't know. I mean,
Is it kind of what?
I think he should
That
sue
one.
for.
Is it kind of
any
like
guy who
Tommy
runs
just
around
saying,
in green
yeah,
tights,
it's
it's just, that's not a hero to me. You know?
Superman.
Superman in blue tights, just not.
He was dating green.
Was it someone?
I don't know. Any guy in tights just scares me, so.
Oh, I have something to tell you later.
Okay, so,
Swipe.
example 34.2 on page 156. When the sheriff began his pursuit. All right, so we've got the sheriff starting his pursuit. When he starts his pursuit, Robin Hood is already 7 miles ahead. So there's Robin Hood. Okay? So when the sheriff starts his pursuit, he's there. Robin Hood's already 7 miles down the road. Okay. I don't really care about anything else at this point except my distances. So, that's the distance of Robin Hood, and this is the distance the sheriff is going to have to go in order to catch Robin Hood. So, if the sheriff catches up to Robin Hood, which in this one he does, he's going to have to travel quite a bit faster in order to catch up because Robin Hood's already 7 miles. So Robin Hood, we don't really care what's going on here. It could have been that 3 days ago he rode 7 miles out of town and he's staying at some inn out in the middle of Nottingham Forest. Is that the name of it? Nottingham Forest? Sherwood Forest. Sherwood Forest. Okay. So
So it would be.
let's look at what we have here. We have
Plus 7 equals 6.
dr plus 7 miles equals the distance the sheriff went.
Which one?
Next step would be to just translate these to the rate times time of Robin Hood plus 7 equals the rate of the sheriff times the time of the sheriff. And now all we have to do is start filling in our variables. So, let's see what it says here. The sheriff traveled 6 miles an hour, so the rate of the sheriff was 6. And how fast is Robbie going?
2.5.
2.5. So let's call that 5 over 2. That's 2.5.
Could you
But
say 2.5?
I don't care.
I don't care.
Okay, so 5 over 2. Do we know anything at all about time?
No. Oh, wait, yeah.
Yeah.
No.
The time of Robin Hood and the time of the sheriff, how do they compare
They're
to each other?
equal.
They're equal to each other. So time of Robin Hood equals the time of the sheriff.
But how did he just, oh, he just started 7 miles an hour?
Yeah, he hadn't already been traveling. It's just that when the sheriff started, Robin was 7 miles out of Nottingham. Okay. So at this point, we basically have our formula. So 5 times the time that Robin Hood was on the trail, plus 7, equals 6 times. If we put the time that the sheriff was on the trail, now we have 2 variables. But since they're
I just changed
equal,
both of them to TS.
we can either change them both to TS or TR, doesn't matter, because the T is the same. All right, so at this point, we can figure out what TR is, but we have a fraction there.
Dang.
Talked about yesterday, if you have an equal sign, you can get rid of the fraction. If you don't have an equal sign, you can't get rid of the fraction. So, your options are find your denominator, multiply the entire thing by that, and your denominators disappear. And then you can go ahead and find your
What'd you
TR. I just multiplied the entire equation by 2 so that those would cancel.
Oh. I like that better than what I
So 14 equals what? So the time Rob was on the trail was 2 hours. Is that what I'm looking for?
No.
Yes.
Yes,
No.
technically.
How long
Yes.
did it take the
No.
sheriff to catch up?
So technically, yes, because the times are equal.
Yes. So the time Robin Hood was on the trail was the same as the sheriff. And he caught up.
Happy
Easy.
days. Happy days.
Until I forget
Okay.
He caught up, it doesn't say he caught.